So for a better estimate, you find n of 0.6, n of 0.9, construct the trapezoid, which looks just like this. I mean, I'm not sure I'm going to get the slope exactly right, but here's n of 0.6, and I should have given myself more room. Here's n of 0.9, here's 0.6, and here's 0.9, right? Now, you can get these numbers, but you do need to use your calculator to do that. Don't try to find n of 0.18 or e to the 0.18 in your head. Although, when if you had a year of calculus and understand sequence and series, you could actually do that pretty well. Okay? Once you get the Taylor series and stuff, but that's in the future, and we're certainly not going to go with that. And in general, you have A and B. You have n of A and n of B. And you could calculate the area, right? Mm-hmm. Now that's the area of the trapezoid, and in this case, that thing is getting pretty straight, but it doesn't go concave up until you get to about this point. So here, it's still concave down, so you're going to get a little bit of an underestimate, right? Mm-hmm. Yep. Okay? If you didn't understand it, look at the video someday. Might not have time between now and tomorrow. Now, if you want an even better estimate, what can you do? Not very well drawn, but you split that trapezoid up, right? Mm-hmm. Really easy to do with Excel. We're going to do it later, okay? But you can imagine, you just put the 0.6, 0.7, 0.8, 0.9 into Excel, and it equal, e to this cell squared over this, right? Mm-hmm. And you get it. Yeah. See? So Excel will do that very easily. Now Wolfram Alpha, of course, will do the integral. Okay? Or that you do so this is an improved estimate, and I'm not going to work that out. You can work that out easily if you have the formula. Not hard to understand, to remember, e to the negative z squared over 2, right? Or to get the exact, that's how you write it. Now, nobody knows what the exact result is, okay? Because do you know what Wolfram Alpha does to get this? They just do this. Maybe for 1 million subdivisions, or enough subdivisions that they can give you an answer that they know is accurate to whatever number of significant figures they spit out. But this is all Wolfram Alpha can do with that. It's all anybody can do with that. Now, they're actually improved methods, okay? And I'll just mention the improved methods. They don't really do this. What they do is they do a quadratic approximation between here and here, and then a quadratic approximation between here and here. So they do a quadratic fit, essentially. Now, there are shortcuts to the way they do that, but that's essentially what you can do, which means that you can get, if you use 10 times as many increments, the quadratic approximation gets 10,000 times better. Whereas the trapezoidal approximation only gets 100 times better. Okay? So you got to do a little more work if you use 10 times the number of increments. Maybe you got to do, twice as much work as you would with 10 times as many increments in the trapezoidal, but you get 100 times the accuracy. And that's a total subject that's, we're not going to touch. Again, you need to have a year of calculus and understand Taylor series and stuff that you'll get about next March if you're taking calculus, okay? About halfway through, a little more than halfway through your second semester, provided you take calculus at a good university or a good school. You would get it from us. You would get it from Will. okay? And you would get it from many community colleges, many universities, okay? But there are universities in Virginia, and especially in other states, where you wouldn't see it, okay? Because they're trying to teach calculus to students who shouldn't be in the calculus course, either through aptitude or work habits or background, okay? Mostly work habits and background. Okay, well, keep that in mind.